By the way, I spoke earlier today. I opened one of the opening keynotes. I was wondering who heard me speak in the morning. Just a show of hands. Okay, so a few. All right, so I can give the same talk again. Nobody's going to know, right? Okay, no, it's not going to be the same talk, but I want to start off with sort of talking on a topic that I mentioned briefly as part of my sixth wave. So I talked, for those of you who did not make it that early today, I talked about how AI moves through different phases, has moved over the past half century and will continue to move. And every time AI can do something new, it sort of is transformative. It is able to do something that just a few years ago we thought was impossible. And it went from playing chess and doing trivial things like that to driving cars to doing new capabilities. And one of the things I want to talk about today is creativity, because a lot of people will sort of think that creativity is one of those things that machines can never do. We're already used to machines being able to predict the stock market. That's nothing. That's easy. Predicting the weather, sure. We can have AI that predict what song you're going to listen to, what product you're going to buy, what link you're going to click on. We're already used to AI being able to do analytical stuff, but these are all things that have to do with consuming data and making decisions. Even driving a car is basically taking in a lot of information from cameras and sensors and deciding, should I turn left or should I turn right? Should I slow down or should I accelerate? It's consuming data, making decisions. And we're, by now, comfortable with the fact that maybe machines will be better than us humans in consuming data and making decisions. All right. So that's one type of intelligence, but I want to argue that there is a different kind of intelligence which is not about consuming data, it's about creating new things. And we call that creativity. And in fact, creativity is often doesn't start with a lot of information. It starts with a seed of an idea, and it creates more and more things out of sort of almost thin air. Now, frequently people will say, you know, computers can do all these things, but only humans can be creative. I recently heard a commencement speech at a university in the US where the speaker said, as long as your cell phone rings, as long as you're creative, you will have a job. As long as you're creative, machines cannot do what you do. And I want to question that, because creativity is a really interesting thing. Now, creativity is something that we all crave. We all believe that inside each of us there's something magical that's creative. Creativity is maybe one of those things that differentiates us from all other life forms. We aspire to have our kids be creative. When you talk to parents about their children, frequently they talk about how curious and creative their kids are. We even want our organizations to be creative, right? We crave that. I've been to lots of conferences around creativity. How do you get your employees to be more creative, even though we don't always want them to be creative, not too creative, but somehow we crave that. So how can we do this? So it boils down to two types of intelligence: analysis versus synthesis. Analysis, consuming data, making decisions. We're very good at teaching this to people. We're very good at teaching this to machines. We've sort of done that. The next big wave of intelligence in machines is synthesis, is creating new things. Now, the truth is that even in academia, when we teach engineers creativity, how to design new things, it is very difficult. We don't know how to teach that. We can teach analysis all day long, how to solve equations and whatnot. But when it comes to being creative, we don't know how to teach that. We still do it by apprenticeship. We take engineers, we show them how we design things, and we hope that by the time they've designed something 50 times, they already know how to be creative. There's no other way to do it. So we're trying to imitate humans in trying to do that. So I want to talk about three different ways in which we can get machines to be creative. And what I want to sort of plant the seed in your minds is, when we talk about the future of work, the question in front of you is, will some aspects of creativity be commoditized? And what would the workforce look like when certain types of creativity can be done automatically. So the first type of creativity is the easiest to explain, and that's rule-based creativity. So what's rule-based creativity? You can show somebody how to be somewhat creative just by following a set of sequence of rules. Best example I know of that, if you want to be a creative artist, there are gazillion books that will teach you step by step how to create portraits. You start by creating these drawings, and you make these ellipses, and you break it this way and that way, and you're not going to be Picasso by doing this, but you're going to be, quite not too bad in creating drawings. These are rule-based processes, and we can teach computers to be creative in that sense of the world. And it turns out that a lot of activities that we consider creative, from designing content for a website and so on, can be broken down to steps, and those kinds of creative processes can be automated fairly easily. But I want to take it a step further and talk about a different process that we use frequently in AI for creativity, and that's a process based on evolution. And evolutionary processes that we see in nature no doubtedly created very amazingly creative things. All kinds of creatures and animals and plants, and we want to harness that same analogy of an evolutionary process to create also physical things. So here's an example. Let's say you wanted to design a robot. How do we design a robot? Traditionally, an engineer would sit down at a table and sketch out all the parts, the nuts and the bolts, program it, and so on. But here's a different approach. We're going to breed robots. How are we going to do that? Using evolution, we're going to start with a bunch of basic machine components, bars, motors, nuts and bolts, all kinds of pieces, and we let evolution put them together randomly, check how far they walk, take the better ones, crossbreed them with other robots that can walk, and keep on doing it for a gazillion of generations until something comes out. So if we do that, we play it out, we get lots of interesting things, and here, for example, go back, sorry, two robots that came out of this process in simulation. This is thousands of generations inside a computer, and here they are using a 3D printer crawling around the lab. These are the first two robots crawling around the lab, made completely autonomously by a process that basically is breeding robots and then printing them as they come along. So they look very different than a robot than you would traditionally expect, that were designed through this evolutionary process. Here's one of them. So you can do that with all kinds of things. Here's another example of a machine that is designing robots from soft material. And again, we throw in these materials. We say, make something that can walk. Go home, you come back the next day, there's a parade of these strange looking machines, all designed automatically by this process of evolution. Again, very different, very strange, very alien to the kind of design we human designs. But this, if nothing else, can be inspirational for humans, engineers, that look at this and see get new ideas. Now you can apply this idea to almost any kind of creative challenge you want, from designing circuits, electronic circuits. I know this doesn't look like creativity to you, but trust me, for the electronic designers, this is the most creative thing they've ever seen. Okay, this is a circuit that you can take out any component and it still works. It's an amplifier, something that no human can design. This is an antenna I showed this morning. Doesn't look creative to you, but for the antenna designers, it's the most creative antenna they've ever seen. It outperforms any antenna designed by a human. So powerful, it's on a space mission right now. And you can use it to do all kinds of things. Here's another example of people who look at letting the computer design the layout of a workspace. Where to put who. These people don't like to be next to each other. This group always needs to talk to those. These three people hate each other, they don't want to be near. All kinds of constraints and issues, and the organization works out, and you can create all kinds of new workspaces. Lots of different ways in which people use this process of creativity. But I want to show you one thing that really fascinates me, and this is the idea of deep learning. So deep learning is a process I showed earlier. A couple other speakers mentioned it. It's this recent kind of machine learning that starts with something like an image and can decide what it is. For example, is it a cat or is it a dog? All right, a very simple process, it goes through this many layers. But then we found something very, very interesting. If you feed an AI an image, it can tell you if it's a cat and a dog, or a dog. Okay, we can understand that. But here's the really cool thing. It turns out, we found by surprise, that if you feed, let's say it tells you 1 if it's a dog or 0 if it's a cat. If you put in a 1 or if you put in a 0 here and you feed it backwards, then you reverse the whole process, and what comes out the other end is a new picture of a cat. Not a cat that you've seen before, a new cat, a creative new cat. In other words, the machine learned something and it can generate new ideas. So it sort of works backwards and it can generate new things. So here, this cat is completely new. It's not a real cat. It is a cat that was generated by an AI just by running it backwards. All right? So it's as if I showed you lots of chairs and I say, now design a new chair. So it'll be very hard for you, but you will design a new chair. Basically, you're doing this kind of thing. Okay, this is sort of a really astonishing finding in sort of almost psychology of AI, that you can run these systems backwards, and instead of making decisions, they become creative. And if you're bored on a telecon one day, you can go to this place, thiscatdoesnotexist.com. And you can see if you can tell the difference between real cats and fake cats, just to test the AI. All right, so you can do this for all kinds of things, for pictures of people's bedrooms, generally speaking, products. What does it mean, for example, when you have product designers coming up with new televisions or new bicycles, when machines can start creating these things from scratch? So certainly there's an element of creativity here that we traditionally don't associate with machines, but they're able to do that. I showed earlier this morning how machines can design proteins, fashion even. Here's an example of a machine that works together with a human. This is for designing jewelry, showing all kinds of shapes. Humans, it actually works with the eye gaze, look at certain things and don't look at others. The machine takes all that information and generates new variations. In other words, it sort of helps you breed. It looks at what you like and what you don't like and generates new ideas for you. This is another example that I showed earlier. This is my pet project, a machine that paints oil paintings and learns to do that. Beginning didn't paint very well, but now it paints pretty nice paintings of all shapes and sizes, oil paintings that are sort of better than what I would say most people can paint, including completely new paintings out of thin air. This is a painting of a flower that doesn't exist. In fact, right now, I checked on it, it is taking a trip. I don't know where this is exactly, but maybe you can recognize this. It's walking around in Google Street View, and it is experiencing things. This is what it's seeing. And when I come back home, I'll see what it paints. It's going to paint something from its experience in things that I have not seen and I have not experienced. So these machines are not just creating things that I have experienced and told them, but also things they're seeing for themselves. So I don't know where this is. I don't know what it is, but it's interesting to see that unfold. Somebody asked me in one of the breaks, can machines write text and create poems and things like that? The answer is yes. I think they're still not quite at a human level, but they're quite interesting. Again, if you're on a boring telecon, you can go to this, Bought or Not, and you can try to read all kinds of poems and see if you can tell if they're real or not. And I'll end with this example, which is one of my favorite. This is an AI that listens to people, and then it learns how to generate human voice in a very natural way. It doesn't understand what it's saying, but it's learning to speak in a human voice. So it's basically, the way it works is you have two AIs, one AI learning to speak, another AI listening and telling if it is a human speaking or a machine speaking. And they talk to each other many, many times, back and forth. But after doing that, in the beginning, one AI doesn't sound like a human, the other one can't tell the difference between a computer and a human. But after doing this for many, many generations, they end up speaking in a pretty natural voice. Let's take a listen to what it sounds like in English.
Aspects of the Sublime in English Poetry and Painting, 1770 to 1850.
All right, so you can do that in any language you want. Here's Chinese.
有众多小运河通过该镇，码头边种树环绕。
Now, I don't speak Chinese. This sounds pretty good to me. And I wonder what it's saying, but it's still interesting they can do it. Here's one more example where the machine tries to create a completely new language, a made-up language that sounds human, all right? So it reminds me when I was a kid, we used to play this game. We would go to the backyard and we would pretend we're speaking Swedish. We didn't know a word in Swedish, but we still pretend that we're speaking Swedish. Here's a computer pretending to speak in a made-up human language. Take a listen.
Sen ydwetha still German, but in the book in citometry, Gerald at the Fed and Deco Kennedy at school. I'm twice.
Isn't this amazing? A future AI will not have a Darth Vader voice, all right? It's going to speak to you in a sweet Swedish voice like this, and you won't be able to tell the difference. And my really favorite example is an AI that creates music. This is an AI that learns how to create a piano concerto. And the way it learns, it composes music, it plays it to another AI that is learning to be a critic. Now in the beginning, the critic doesn't know what's good, what's bad, and the composer cannot generate anything. But they go back and forth, composing and critiquing a gazillion piano concertos a second. And in the end, here's a piece from something that the first AI composed. Let's take a listen. So this is an AI that not only composed this, it also created the sound of a concert grand piano, then played it with emotion. All of that from scratch. So we're seeing a lot of activity around creativity. Creativity is the newest wave of AI. It's still bubbling in academia. It'll probably take a few years before it reaches mainstream commercial applications. But I thought it would be useful for you to know that this is coming, that creativity is going to become a commodity, and we have to prepare for this. Thank you.